So let's do an example with t and b. Find t, n, and b if this is the r of t that we've been using for the point pi over 2, 0, and 3. So in other words, we need t to be equal to pi over 2. So let's begin by calculating t, which we have been doing for a while now, which, remember, is just going to be r prime of t over the magnitude of r prime of t, which we found this several times, so I'm going to just write it as 1 over the square root of 10. And then if we look at our function here, what is r prime? It's just going to be 1, 3 sine of t, the negative of that, and 3 cosine of t. So we get our t value being 1 over square root of 10, negative 3 sine of t over square root of 10, and 3 cosine of t over the square root of 10. Now, this is a pretty tame function, so what we're going to do is differentiate r prime. We're going to differentiate t. So t prime of t will just be 0, negative 3 over square root of 10 cosine of t, and then negative 3 over square root of 10 sine of t. The magnitude of this function can easily be seen to just be equal to 3 over the square root of 10, just because of the properties of sine and cosine. So we already had that t. So if we are looking for our n of t, this is just t prime of t divided by the magnitude here. We are going to be getting up 0, negative cosine of t, and negative sine of t. So the last thing we need to do is find b, which was just t cross n. So we take our I, j, and k hats, and we are finding the determinant of what's t? 1 over square root of 10, negative 3 sine of t over square root of 10, and then 3 cosine of t over square root of 10, and then 0, negative cosine of t, negative sine of t. So we do our determinant, and for I hat, well, we get 3t plus 3 cosine of t, and we're going to get 3 over the square root of 10 for this one, because sine squared plus cosine squared equals 1. For here, we have a negative and the 0 there, so we get plus sine of t over the square root of 10. And for k, we get our negative cosine of t all over the square root of 10. And this is going to be our b of t. So now we found our tangent vector, normal vector, and binormal vector. So let's find the normal and oscillating planes. Now, at this point, remember we found t equals to pi over 2. So which ones do we need? For the normal plane, we're going to need the tangent vector, right? So the tangent vector at pi over 2 is going to be equal to 1 over square root of 10. Then pi over 2 of sine is 1, so negative 3 over root 10, and then 0, right? So we use this to find our normal plane. And we get that the dot product of this and the point x minus pi over 2, y minus 0, and z minus 3 needs to equal 0. And we could just leave it in this form, or you can make it look all nice, but I'm going to let you do that. For the oscillating plane, we need the b of pi over 2. And we just get here that when we plug pi over 2 in for b, 3 over root 10, 1 over root 10, and 0. And again, in order to create a plane, we just take our dot product with the point that we're looking at and set it equal to 0. And we could distribute it out once again if we liked. So a comment on the normal and oscillating plane. Recall we only need a vector which is perpendicular to the plane to find the equation for it. And in particular, the length of the vector doesn't matter. So if we are creating this normal plane, we don't need to divide by the unit vector. So we could just use r prime of t. And for the oscillating plane, we could just use r prime of t cross r double prime of t, since we don't need to normalize those units, those vectors. Hopefully this example helped you, and we can find our TNB frames.